Let me ask you something so simple it sounds like a trick. There is an ant standing at one end of a long rubber band. At the far end, about a yard away, sits a single drop of honey. The ant starts walking toward it, slow and steady, the way ants do, one patient little step after another. And while it walks, I take both ends of that rubber band and I pull. Every second, the whole band gets longer. So here is the question. Does the ant ever reach the honey? Most people answer before I have even finished asking. They say no. Obviously not. The honey keeps running away. The poor little thing is marching down a road that grows under its feet faster than its legs can ever cover it. Give up, ant. Go home. You will never make it. And most people are completely, beautifully wrong. Let me show you why, because once you see it, I promise you will never look up at the night sky in quite the same way again. Picture the band stretched out in front of you. The ant takes a step, a small step. Meanwhile, I stretch the band, and yes, the honey jumps a little farther away. So far, the gloomy crowd seems to have it right. But look closer at what the stretch does to the part of the band behind the ant. That part stretches too. Every inch of road the ant has already walked gets longer, and as it lengthens, it carries the ant forward along with it, for free. The ant did not pay for that motion with its legs. The stretching handed it over as a gift. So here is the secret almost nobody sees coming. The ant keeps everything it has already won, and the stretch makes those winnings bigger, and then on top of all that, the ant adds one more little step of its own. A tiny bit of progress, plus a tiny bit, plus a tiny bit, again and again, with no end. You might think a tiny bit added forever is still as good as nothing. That is the trap. A tiny amount, added over and over without stopping, can quietly pile up into everything. The ant's share of the whole journey, the fraction of the band it has already crossed, keeps creeping upward, and it never stops creeping. And if it never stops, then sooner or later it must reach the far end. The ant gets the honey. Let me put a sharper edge on it. Say in the first second the ant claims 1/100th of the whole band for itself. Good progress. But now the band is longer, so in the next second that same little step is worth less, maybe 1/200th of the new longer band. The second after that, less again, 1/300th. The slices the ant wins keep shrinking, smaller and smaller. And yet, if you add up 1/100th, and 1/200th, and 1/300th, and 1/400th, on and on without ever stopping, that total has no ceiling. It climbs past 1/2, past 3/4, past 9/10, past everything. If only you give it enough terms. That is the quiet little miracle hiding in the band. Shrinking slices, added forever, can still cover the whole loaf. It might take a stretch of time so monstrous that the band by then is wider than a city, wider than a planet, wider than anything you can picture. The honey could be 1,000,000,000,000 miles off by the time the ant finally arrives. But arrive it does. I find that delightful. The slowest walker you ever saw beats a road that is actively running away from it, just so long as the road runs away at a steady pace. Hold tight to those 4 words. A steady pace. Because everything that follows, everything, hangs on them. Now I am going to change exactly one thing. 1. Instead of stretching the band by the same amount every second, I am going to stretch it faster and faster. The first second I add a little. The next second I add more. The second after that, more still. The band is not merely growing now. Its growing is itself growing. Ask the question one more time. Does the ant reach the honey? This time the gloomy crowd is right. And here is the part that aches a little. It is not that the ant has gotten lazy. The ant never tires, never pauses, keeps laying down its faithful little steps forever, exactly as before. But the fresh road appearing out ahead is now piling up faster than the ant's winnings can ever match. Watch the ant's fraction of the journey. It still climbs. But now it climbs toward a ceiling and stalls. It reaches, say, halfway, then crawls toward 2/3, then inches toward 3/4, and it approaches some number and never, not in all of eternity, passes it. The honey sits just on the far side of that number, near enough to see, forever out of reach. And notice something strange and important hiding in this. Whether the ant makes it no longer depends only on how briskly the ant walks. It depends on where the honey started out. Set the honey down close to the ant, and the ant still wins, even with the runaway stretch. Set it far away, past a certain line, and no amount of patience in the universe will ever be enough. There is, in effect, a circle drawn around that ant. Honey inside the circle, reachable. Honey outside it, never. The ant cannot see the circle. There is no wall there, no fence, no mark painted on the rubber. And yet it is as real and as final as any boundary that ever stopped anything from getting anywhere. Remember that invisible circle. We are about to go find it in the sky, because the universe, as it happens, is a rubber band. Not one you can pick up, but the very stuff every rubber band is made of and floats inside. Space itself. For the longest time, people imagined space as nothing more than the empty stage where the play takes place. The actors stride about. The stars and planets do their slow dance, but the stage stays bolted to the floor. The stage is nailed down. Well, the stage is not nailed down. The stage is stretching. Here is how we came to know it. Point a good telescope at the distant galaxies, those vast islands of 100 billion suns apiece, and you find almost every single one of them is moving away from us. The light itself confesses this, because light coming from something that rushes away gets stretched out, its color sliding toward the red, the very same way the pitch of an ambulance siren sags downward as it tears off past you down the avenue. The galaxies are reddened. They are leaving. That part is curious, but it is not the shock. The shock is the thing Hubble spotted. The farther away a galaxy sits, the faster it flees from us. Twice as far, twice as fast. 10 times as far, 10 times as fast. If the galaxies were simply hurtling through space, like fragments blown out from one great bomb, that tidy pattern would be a strange coincidence. Why on earth should the distant ones travel faster? But there is a cleaner explanation waiting, and it is the true one. The galaxies are not flying through space. The space lying between them is growing. Let me make that real in your hands. Forget the band for a minute. Take a lump of raisin bread dough, the kind you leave to rise on the back of the warm stove. Stud it all through with raisins. Now let it rise. Every raisin just sits there in the dough, not crawling anywhere, not swimming, doing nothing at all. But as the dough swells, the gap between every pair of raisins grows. Pick any raisin and call it home. Look out from there. The nearby raisins drift off slowly. The far raisins drift off quickly, because there is more dough stuffed in between you and them, and all of that dough is puffing up at once. More dough between, more swelling, more speed, twice as far, twice as fast. There sits Hubble's pattern, falling right out of a loaf of breakfast bread. And here is the wonder of it. No raisin is special. Stand on any raisin you like, and you see precisely the same view, everyone running away from you in every direction. Nobody is at the center, because the swelling has no center anywhere inside the dough. It is happening everywhere all at once. We are not perched at the middle of some cosmic explosion. There is no middle to perch on. There is only the stretch, the same in every direction, seen the same from every home. I want you to sit with how odd that is. Everyone is at the center, which is only another way of saying nobody is. So the galaxies are raisins, and we are riding along on one of them, and the dough of space is rising all around. Fine, you say. The galaxies are running off. So what? I will build a ship. I will build the fastest ship the laws of nature allow, and I will simply chase one of them down. How fast can my ship go? There is a speed limit posted in this universe, and it is the speed of light, around 186,000 miles in a single tick of 1 second. Nothing with any weight to it can quite touch that speed, but let us be generous and dream a little. Suppose our alien engineers are very, very clever, and they build us a ship that flies a whisker under the speed of light. Surely, we can reach any galaxy we can see. We can see it, can't we? Its light got all the way here to our eye, so we just turn around and follow that light back the other way. Right? And this is the moment the rubber band comes for us. Think hard about what the light from a distant galaxy actually did on its way to your eye. It did not stroll across a fixed distance like a runner crossing a still field. It crossed a distance that was growing the entire trip. The light was swimming upstream against a current of expanding space the whole way. For light coming from close by, the current is weak, and the light reaches us quickly and easily. But for light setting out from very far away, the current is fierce. And for galaxies far enough off, the current of expanding space is flowing faster than light itself can swim. Sit with that one. The space stretching out between us and a distant galaxy can grow faster than the speed of light. The galaxy is being carried away from us more quickly than any beam of light could ever crawl toward us. I can hear the objection already. Wait, you say, I was promised nothing can go faster than light. And you were promised correctly. Nothing can move through space faster than light. But the galaxy is not moving through space. It is sitting perfectly still, like the raisin, doing absolutely nothing. It is the space in the middle that is growing, and there is no law anywhere on the books against space growing just as fast as it pleases. The famous speed limit is a rule for things racing across the stage. It says not one word about how quickly the stage itself is allowed to stretch. The galaxy breaks no rule. It simply rides an opening tide of pure nothing, and that tide can rush at any speed at all. Put 2 ants on that band instead of 1, sitting near opposite ends, both of them honest, both crawling along at their proper little ant pace. Now stretch the band good and hard. The 2 ants fly apart, the gap between them widening faster than either ant could ever crawl. Did either one cheat? Did either break the crawl limit? Not for a single instant. Neither ant ever moved through the rubber any quicker than an ant can move. The band itself did all the rest. That is precisely the trick the universe is pulling with the far galaxies. Every galaxy obeys the local rule perfectly. The space sitting in between answers to no such rule at all. Feel the trap easing shut. Our ship flies almost at the speed of light. But it is trying to cross a sea of space that, once you go out past a certain distance, is itself opening up faster than light. The ship is the ant. Space is the rubber band. And we have already learned, the hard way, what becomes of an ant on a band that stretches faster than the ant can walk. The honey, the galaxy, sits beyond a number the ship can never pass. Imagine the crew aboard that ship. They aim it at a galaxy they have watched and loved through the glass for generations. They light the engines. They climb to very nearly the speed of light, and they hold it there, steady. Then they check their target. It is farther away than when they began. They push harder, farther still. The years roll past inside the ship. Then the centuries and the galaxy they are chasing does not swell any larger in the window. It shrinks. They are the fastest travelers in all of history, and they are quietly losing ground. There is no enemy out there to fight, no broken engine to mend, no navigation mistake to correct. The road itself is winning, and the road never tires. So here is the picture, and it is a strange one, and a beautiful one, and a little bit terrible all at the same time. Around us, around our own galaxy, there is a circle. We cannot see it. There is nothing out there to mark it. No wall, no edge, no sign hammered into the dark. And yet it is the single most important boundary in all of nature. The people who study these things call it the cosmic horizon. Inside that circle, the galaxies sit close enough that if we launched today at nearly the speed of light, we could one fine day actually arrive. Outside that circle, it is hopeless, not difficult, not expensive, not a matter of inventing a cleverer engine. Hopeless in the exact way that reaching last Tuesday is hopeless. You may aim your fastest ship at the brightest galaxy beyond that line, and it will fly forever, and it will never, ever get there. The space in the middle keeps opening faster than the ship can swallow it. And now we arrive at the part I find almost unbearable, in the good way. the way a certain piece of music can be almost unbearable, you can still see those galaxies. They are hanging up there in the sky tonight, glowing, lovely, clear as a bell through a decent telescope. So how on earth can you see a thing you can never ever reach? Because the light you are seeing is old. Terribly, achingly old. It set out from that galaxy long, long ago, back when the galaxy was closer, back when it was still safely inside the circle, back when the current of space was gentle enough that the light could fight its way across the gap to us. That light has been swimming upstream for billions of years to land in your eye tonight. It is a postcard. And like any postcard, it shows you a place as it stood when the picture was snapped, not as it stands today. The galaxy that mailed it has long since drifted on past the line of no return. You are gazing at a photograph of a friend who packed up and moved away ages ago and left no forwarding address. The light is real and right there in front of you. The friend is gone. That, at last, is the answer to our riddle. Why does the fastest possible ship still arrive too late? Because by the time the light from a far galaxy reaches us to whisper, "Come and visit," the galaxy itself has already slipped out of reach. We are forever chasing an image of a place that no longer waits for us. The invitation arrives, and the door is already shut behind it. And it is stranger still, because there are really two different edges out there, and people forever mix them up. There is the farthest we can see, set by how long light has had to travel to us since the very beginning, and there is the farthest we can ever reach, which sits much closer in. Between those two edges lies an enormous zone of galaxies that are perfectly visible and completely unreachable. We can read their ancient light all night long. We could never once shake their hand. Most of what crowds into our telescopes, as it turns out, lives right there in that no man's land. We can see far, far more of the universe than we could ever dream of touching. Now you have every right to stop me and ask a hard question. Hold on, you say. The ant only got trapped once the band started stretching faster and faster. On the steady stretch, the ant always won in the end. So which is the universe actually doing? Is space stretching at a nice steady pace, in which case patience might still carry our ship through, or is the stretching itself speeding up, slamming the door for good? This is the deepest layer of the whole business, and I am going to be honest with you about what we know and what we are still guessing. For a long while, the natural bet was that the expansion ought to be slowing down. Think about it. Every galaxy tugs on every other galaxy through gravity, and gravity is an attraction, a pull inward, a hand reaching back. All that mutual tugging should be putting the brakes on the stretch. The way a ball you toss straight up is slowed by gravity on its way to the top. If that were the whole of the story, there might be no firm circle at all. Given enough patience, enough time, our ship just might reach almost anything it pleased. But space may hold more than emptiness. When Einstein first wrote down his equations for the whole universe at once, he found they refused to sit still. They insisted the universe must either grow or shrink. He did not care for that one bit. So he added a term by hand, a kind of springiness built into empty space itself, a tendency for the vacuum to push outward, to stretch all on its own, with no matter required to do the pushing. He tuned it just so, to hold the universe politely still. Later, the story goes, he called it the greatest blunder of his life. But a blunder, once handed to nature, has a way of turning out to be no blunder at all. Because if empty space truly does carry a push like that, a built-in itch to stretch, then watch what happens. The more space there is, the more pushing there is, and the more pushing there is, the more new space appears. And the more new space appears, the more pushing there is again. You can see the runaway coming. That is not a steady stretch. That is a stretch that feeds on its own appetite and grows faster and faster, exactly like the cruel rubber band that trapped our ant. Exactly the case that draws a hard circle around us and locks the bulk of the universe outside it forever. It is a fire that makes its own fuel, a rumor that spreads itself faster the more people it has already reached. So this enormous question, whether the sky is ours to go and explore or forever sealed away beyond our touch, comes down in the end to one quiet little property of empty space. Does the vacuum push? Is there a hidden springiness inside nothing itself? We measure, we argue, we squint at the faint light of distant exploding stars, and we are still working it out, and I will not stand here and pretend the final verdict is in. But if that push is real, and the stretching is indeed running away with itself, then the circle is real, and it is closing. The honey is rolling past the line even as I stand here talking to you. Let me leave you with where this road runs out, if the push turns out to be real, because it is a thought I do not think you will set down easily. If empty space keeps stretching faster and faster without end, then one by one, across spans of time too vast to hold in the mind, the distant galaxies will cross our circle and slip out of reach. They will not blow up. They will not die. They will simply slide away, their light stretched redder and dimmer, until at last it is too faint and too feeble for any instrument to catch it all. The far sky will quietly empty itself out. The grand crowd of 100 billion galaxies will thin to a handful of near neighbors, and then perhaps to none whatsoever beyond our own little island of stars. There will come a time, deep in the future, when some thoughtful creature on some far world lifts its eyes and sees only its own galaxy adrift in a great surrounding blackness. And it will have no way to know, no way at all, that the blackness was once brimming with light, packed with countless other islands, crowded with company. The evidence will have sailed off past the horizon and gone. That creature will study the heavens just as carefully and just as cleverly as we do, and it will conclude reasonably, sensibly, and utterly wrongly that its single galaxy is the whole of all that exists. We are the lucky ones. We happen to have been born early enough, while the postcards are still dropping through the slot, while the light of the far galaxies still reaches us to swear that they are out there. We get to know about the great crowd before the room empties. That is a kind of gift, to arrive in time to see the company before the lights go out one by one. So the next time you stand out under a dark sky and find some faint little smudge of a galaxy hanging in the black, I want you to feel two things at the very same instant. First, that you are looking at something almost beyond comprehension in its distance, an island of 100 billion suns. And second, that you may well be looking at a place no ship from this earth could ever reach, not in 1,000 lifetimes, not at the full speed of light, not ever, a place you can see with your own eye and never, never touch, a light from a door already swinging shut. Here is the thought I would like you to carry off with you tonight. If you could send a single message, traveling at the speed of light, to just one galaxy out there before it crosses the line forever, which one would you choose, and what would you want it to say?